Just now we discussed simple logistic regression. Why it is simple logistic regression? Because we used only one single predictor variable to predict the output variable. We used only age variable to predict buy. But in real life, we might not be having a scenario where only there is one variable which is impacting the target variable. There can be multiple variables that will impact the target variable. So here the output variable is binary. Instead of single independent or single predictor variable, if we have multiple predictor variables, then we have to build multiple logistic regression line instead of simple logistic regression line. The idea is very much simple to the very much similar to the multiple linear regression line that we have built, right? Instead of simple linear regression line, we wanted to build multiple linear regression line because there are multiple factors that are impacting the target. Just like that, here the buying or not buying, the sales example, multiple factors like customer age, gender, place, income, buying patterns, the expenses, all these might impact customer buying or not buying a particular product. So the model building also pretty much similar to the model building that we just did for simple logistic regression. Instead of giving one variable in the predictor list, we have to give multiple variables in the predictor list. Not a big difference. You just go ahead and build the multiple logistic regression line with multiple variables as inputs. Everything else remains the same. The output variable is buying or not buying. Output variable is still binary, yes or no. But all the input variables, we are adding more than one input variable. So the line that logistic regression line will be a multi-dimensional one. It's hard to imagine. So simply you just go ahead and build multiple logistic regression line. So for that, what we're going to do is we're going to consider a data fiber bits. So it's an internet service provider data. So what happened with FiberBits? FiberBits is an internet service provider. In last 2 years, there were some customers who stick to this internet service provider, and there were some few customers who left who attrited or who left the internet service. They didn't continue. In last 2 years, there were some customers who are still using it, and there are some customers who left it. Now what are we trying to do? We are trying to build an attrition model. We are trying to build a model that will predict whether a customer will be there in the network or not. Why are we doing that? Because beforehand itself, today, if we do some kind of model building and see who are the customers who are likely to leave, who are likely to attrite, then we can send some promotional offers to them, or we can send some or we can build some strategies to retain such customers. So active cust is the variable that indicates whether the customer is active or already left the network, and there are several other variables that will be used as predictor variables. There might be several factors for customers to stay back or leave. So we will take this data and then we will try to build a model that will predict whether a customer will stay back or whether a customer will leave. So the model that we need to build upon the data set is FiberBits data. So let us see. You can go ahead and build the model. You can pause this video and build the model and come back, check whether the model that you built is exactly same as the model that I have built, or else you can continue watching this video. This is the FiberBits data, and it has how many rows and how many columns. We have to see that. Let me see the dim of FiberBits data dimension. So there are almost 100,000 rows and 9 columns. What are the columns? Active customers 1 or 0. This is the target variable, which depends. Being in the network or leaving the network might depend on the customer's income, the months on the network, number of complaints they gave, number of plan changes they made, relocation status, whether they relocated or not, the monthly bill that they are generating, the technical issues per month, speed test results, like whether whatever speed that we promised, did they get that speed when they tested it. All those things are there in this data set. So depending on all these variables, we need to predict whether the customer is going to stay back or is going to leave the network. That's what the task is. So what are we going to do? Since the active customer is the output variable, it has two values, 1 or 0. Directly we are going to build a model using rest of all the variables. So I will be writing active customer versus all the variables, that is income plus months on network, number of complaints plus number of plan changes, etc. If we are using all the rest of variables, either we can write all the variable plus variable 1 plus variable 2, x1 plus x2 plus x3 like that, or I can just put tilde dot, which means take everything else apart from active customers. So this is how we can write the model. It's a shortcut kind of thing within R while you are building the model. Active customers versus tilde dot, which means active customer versus all the variables. Family binomial, data is fiber bits, and then the summary of the model. Model building done. So this is the model that will help us to predict. So the model equation will be much more complicated here. So active customer, probability of active customer equal to e power intercept, that is beta naught plus beta 1 x1, that is this coefficient beta 1 into income, beta 2 into months on network, beta 3 into number of complaints, divided by 1 plus e power something. That is how we'll get the equation. If we, for every customer we have the income value, months on network, number of complaints, number of plan changes. If we substitute all of them, then at the end of it we will get a probability. If it is near to 1, that customer might leave. If it is near to 0, that customer might stay back. If a probability is near to 1, then we can start building some strategies, or we can start segmenting out these customers and saying that okay, these are the customers who are likely to leave. We have to actually somehow retain them. It need not be just internet service provider. As a matter of fact, any binary output variable, we can predict the output using rest of the variables if they have the information that is impacting the target variable. So that is how we build multiple logistic regression line.